Hey there, this is Ryan Jones. I am going to go through Jeremy Daly's Off by None, issue number 50, and I'm going to kind of open up the tabs, read it, and I'm going to kind of condense it. The point of this video and the point of the future videos going through the Off by None issues is to A, learn myself, and B, share that knowledge with the rest of the community. I myself, I work as a senior serverless consultant. The CTO and CEO as well of Serverless Guru, and I constantly work with clients in the front edge of serverless technology, and with that I have to be up to date on all the knowledge that I have, and I'm going to use this as a way to push myself as well, to keep up with what Jeremy Daly is doing, as he's releasing new content every single week, and it's super impressive, and it's hard to keep up with all the things that are happening. One of the big things about serverless is that, they say service full, because as you get deeper into working with serverless, you get further away from just having, this kind of like monolithic structure, and even microservices with containers are still a little bit easy to manage. But then when you're on a function level and you have hundreds of functions, that becomes a lot more difficult as well. And so, in that fashion, the same way as a developer, as somebody that's working in tech, you have to constantly be learning and continuously improving and pushing yourself. You have to do that even more so when you're on the bleeding edge, because every single day things are changing, new features are being released. That cool polling thing that you did for SQS, AWS came out with a SQS to Lambda trigger, and now you don't need to do that anymore, but it still has a benefit, and so you need to know that and understand it. And so that's going to be the point of these videos. I hope you're excited for it. If you've been trying to learn about serverless and keep up with all these Off by None and keep up with all the other newsletters, this series is going to focus on reading all of it and going through it and then condensing it and giving my thoughts on the different information. So with that, let's go ahead and get into it. So if you're not familiar with the Off by None newsletter, there's some general information here, and then as you work down the page, they're broken up into different sections. Each one of these are links to different places, and then at the very end, let me see, thoughts from Twitter, serverless events that are coming up, serverless star of the week, which in this case is Rich Buggy, so definitely follow him. And then final thoughts from Jeremy Daly, and then that closes out the thing. So this is a lot of different stuff to look at. I think what I'm going to do is I'm going to open up some of these tabs, and then we'll just get to reading, and then I'll of course chop the video up so it's a little bit faster for you. But let's go ahead and go through the Oracle functions, the serverless September CFP. I'm just going to go ahead and open up all these. What we have here is Oracle functions are now generally available. I just read through it briefly. It's pretty much describing exactly what AWS Lambda does. The pricing is pay as you go, no charge for idle time. Why pay for a function that's doing nothing exactly? They're automatically auto-scaling out of the box. And let's see. They're open for business. Oracle Functions is built on Apache 2.0 licensed function project, which can be used anywhere from a developer laptop to a cloud compute platform. So this kind of looks like the AWS Lambda equivalent, but for Oracle. So now Oracle is actually competing in the space, and they have their own cloud function offering. I haven't actually played with Oracle Functions, so I can't actually speak to the level of it. But yeah, I guess Oracle's now in the game. So there's the first article. Okay, our second article here is From LAMP to Serverless. This is a case study of externals.io. They basically moved their LAMP stack to serverless, and they did that using something called Brev. Not even be saying that correctly, but having these mountains at the bottom and the way that it kind of flows together on the screen, that looks super nice. But it's everything that you need to easily deploy and run serverless PHP applications, so that's pretty cool. It looks like it's using AWS, and it's also, that's the serverless.com logo, although I'm not sure. Yeah, simple cloud orchestration via the serverless framework. So that's pretty cool. Yeah, and then you can get started here. Let's see what it looks like. So they've got some helpful docs in here. It looks like what ends up happening is that you take your PHP application and you're actually moving it to Lambda and API gateway, and then Bref is helping you do that. So let's see if there's anything in here that's interesting enough to point out. So good use cases are in green, some drawbacks, strong limitations. So for performances, are the performances acceptable? Yes, in all of these areas. So jobs, cron jobs, API, MySQL, Postgres website, all that stuff. That's all great. Legacy applications, not so much. Scenario production ready, not so much. But if you're doing websites or APIs, or MySQL Postgres APIs, or cron jobs, for the most part, this is a pretty good solution. So let's look at their serverless.yaml. So pretty normal serverless.yaml, provider name is AWS, runtime, it says provided, plugins, .vendor, bref/bref, the handler is an index.php file, that's pretty cool. Then it has the Lambda layer here that has the PHP -73, assuming that's the version. And it even has like a bref syntax there, that's kind of cool. And then we have resources, my buckets, that looks fine. You can add stage and region on there, just like any other project. You can add a timeout. And then you can add additional functions here. So you have foo.php and you have bar.php. Let's see what else they have. Lambda permissions, that's pretty standard. Pseudo parameters plugin, allowing you to pass things like the bucket error in there. Okay. Let's see, is there anything else I want to look at here? Trying to see, doesn't look like it. Yeah, so I mean, if you're running a LAMP website, something like that, with APIs and all this stuff, and you're looking to move to serverless, then probably check this framework out. This seems pretty solid. If I was running a PHP application, I would definitely check this out. So that's Bref, pretty cool. Something else I saw inside their article is they actually talk about the stack here, about what they're actually using. So Linux, Apache, MySQL, and PHP. This was their original setup that they had. So you can see Nginx /assets with an assets directory, and then PHP websites, a PHP updater, cron job to MySQL and a mailing list. And then they get to the new architecture, and now they have their assets inside of S3, and they're using CloudFront as a CDN on the front. And then they have API Gateway and Lambda, which are serving their PHP website. And then they have a cron job which runs Lambda. There's MySQL in the background and the mailing list as well. Alright, something else that I saw in here was that, let's see, performances. So something that they pointed out was that the medium response time was 55 milliseconds for API Gateway. And they pointed out also, what about cold starts and slow pages? So here are the actual numbers they had. 10 millisecond latency minimum, and the latency maximum was about 3 seconds. So that would be on a cold start, on one of the longer cold starts. The numbers here I thought were interesting. So 90% of the requests are below 100 milliseconds, 1% are above, 0.5% of all requests are cold starts. Sorry, I'm dying a little bit. I'm recovering from being sick. And I was like, you know what? Let's just record a video about 100 articles on serverless, and it might end up costing me my voice. But something else that was interesting was that I think it has a cost in here. So yeah, it said that 1% of requests were 500 milliseconds to 3 seconds, which is not ideal, but it's okay for them. And they also had the cost in here. So externals were previously hosted using platform.sh. The smallest plan was $50 a month. And the monthly cost for the serverless version, they were looking at $17 a month. So they were able to save like, what is that, $33 switching to serverless. And you can see that the RDS database was the biggest hit. And so you could imagine that, you know, obviously this might be a little bit more of a lift, but if you moved RDS to something like DynamoDB, or potentially even worked in like Aurora Serverless with MySQL, which is a possibility now. I don't know if this was a possibility back then when this article was actually written, or when external.io actually made their move. But now you could actually use Aurora Serverless, and this might actually reduce this cost even more. In which case, this could be as low as potentially like $5 to $10 per month, which would be almost I don't know what the actual percentage of that would be, but it's 5 times less than it was before. And obviously that's exponential. So if, for instance, you're paying $100,000 a month for your PHP application at scale, then switching to something like serverless and being able to hit these numbers, that'd be pretty nice. As we saw in the Brev thing, it said it wasn't production ready completely with legacy applications. However, I would definitely look at the specifics of that and see if it worked for you. Cool. Moving on. The rest of the website totals $1.67 per month. The traffic received each month was 5,200 visitors, 100,000 HTTP requests going to PHP, spikes in traffic. What if there's a huge traffic spike? I'll end up paying a lot of money. So they did get one here, and it looks like it cost 0.022 total. So there was a link that was shared on Twitter, Reddit, Facebook, and Hacker News, which brought some traffic. This caused a spike that cost us 1 cent, so literally 1 cent. It doesn't really answer the question of DDoS, which can be prevented using Cloudflare and AWS or AWS WAF, but I hope it gives a sense of scale. Okay, so yeah, that's one thing too, is that if they had CloudFront in front of it, they had not CloudFront, but Cloudflare or AWS WAF, then that would potentially help. I don't know about the WAF example and how that fits in here with the API gateway and Lambda scenario. It might fit, but my brain's not fully firing on all gears or all cylinders at the moment. And then moving to the how to anticipate costs, it looks like over at Brev we have built a serverless pricing calculator. That's kind of cool. Take a look at that. Estimate AWS costs when running a serverless application on AWS Lambda. Cool. So if it was a large API, HTTP requests per month. So this is like 5 million. Average time. Let's see, Lambda size. Looking at like $33. This is actually super cool. I would check this out, costcalculator.brev.sh. If you're looking to do some cost calculation. I don't think this just only works with PHP in mind. I'm pretty sure this is for everything, it looks like. But I would play around with this if you're curious on like what your total cost per month are going to look like. This seems like a pretty decent sized, back in here. Average number of assets per page, 5. Total assets per page, 200. Database cost. So the CloudFront's like $69. This is actually a really cool cost calculator, so definitely check that out. Okay. Let's keep moving down the list here. See if anything else jumps out. Not really. I think most of that's kind of talking about the effort of actually migrating this stuff and some of the code changes that you have to make. So if you're actually considering doing this like external.io did, then yeah, I would probably go through this code and see how this works. Looks like there's some comments on here. Save that for later. Cool. All right, so that's the second article done. That is from Lambda to Serverless, case studies of externals.io, and it is on the mnapoli.fr website. If you're interested in learning more about that, definitely check this out. Okay, so let's close that down and let's look at this next one. Building a minimal Evernote alternative in 6 hours with Amplify. Okay, so it looks like based on that title, if I had to summarize what this is about building Evernote using Amplify from scratch, and it only took them 6 hours to build an equivalent. Cool. All right, so I'm going to pause it here, and I'll circle back after I read a little bit, scan through it, and then I'll talk over it. All right, sweet. So I read through this article by Adam Clark here. Shout out to Adam Clark. There he is. And basically, yeah, he's saying that Amplify is a glimpse to the future of what programming will be, and why he needs to upskill or maybe get a side skill here. So this looks like what he actually built. You can see here, looks like there's a search bar. Looks like there's a couple of side navigations here. The ability to create a note, edit a note probably, delete a note, so it's got full CRUD functionality. It's a micro journaling platform built with React and AWS Amplify. Excuse me. He talks about an awesome article by Jeremy Daly on micro journaling. So I'm just going to open that up. Scan through this. So he says that he has 13,000 microjournal entries that document the last 787 days of his life. That's pretty cool. Detailed notes of practically everything I did since I started this. There are times when I had to go back a few days to piece things together. Mostly on a computer. Spent the last 45 minutes working on the database schema for the profiling system. In my previous post I wrote, I see this as a tool that will let me assess and better reflect on how I live my life. It will let me see how I spend my time and maybe even why I spent time doing things that I did. For me, this means the clarity that I've been lacking. It means getting a better understanding of myself. It means being able to become a better husband and father, a better product manager and engineer, and hopefully a better person. Respect that. And then let's see. Cool. All right. So if you're interested in micro journaling, check this out. Obviously, it inspired somebody named Adam Clark to build a whole article around it and actually build an AWS Amplify and React thing around it as well. So, basically what Adam Clark did here is he took this AWS Amplify with React. He generated some backend code for it using the Amplify CLI. With that, he said within one command, I had an S3 bucket CloudFront distribution deployed. With the next, I had authentication via Cognito with a login and registration screen for the React application. The next command created a GraphQL endpoint via AWS AppSync, and an Elasticsearch instance was deployed. Okay, so that's like 4 commands, and he had pretty much whole backend, whole front end deployed and ready to start working with. Then he started using React Material to create the UI, and with that simple setup, he then had Amplify with auto-generated GraphQL queries and mutations, which were fully authenticated, which is actually takes quite a long time to do by hand. I've done it. All right, so continuing down this path, this is the sign-in screen that gets auto-generated by Amplify. And then on top of that, he's basically talking about here the speed of development was extremely fast, and here's the GraphQL query that was generated as well by Amplify, and you can see there that it's doing a get event here. It passes an ID, it gets back a few fields, and this is all generated by Amplify. And then here are the high-level bullet points of it. What I thought was a domain of a serious backend developers is now a simple single CLI command. This is a basic CRUD application, however, it feels like it's a precursor to something bigger, and maybe even the next step of serverless, right? He also says that Lambda serverless is the glue between services. Not sure what Amplify is, but there's definitely less glue. He talks about micro journaling a little bit and says that it's awesome. And then says, still don't have knowledge about how well AWS Amplify would scale with an engineering team, but he's excited to try it with a production environment. The best thing about this approach is that the only scaling issues I could see are with Elasticsearch. However, there are worse problems to have. So I don't know this to be a fact or not, but I'm pretty sure that I actually don't know if this is true at all. Assumingly, AWS is going to come out with some type of Elasticsearch that is serverless and that scales and it's fully managed and all that. They might already have it. I'm pretty sure they don't, but I could be wrong. I've been focused so much on the consulting business and actually being a practitioner of serverless that sometimes those little announcements they slip by. So overall, I think this is a good article. I think it gets people excited about Amplify. I've personally used Amplify for a lot of different projects, both for clients and personal projects. I followed Nader Dabit quite a bit, who's a developer evangelist. Y'all should follow him on Twitter. That is the Amplify article, so let's close that out. Now up we have how we reduce Lambda function cost by thousands of dollars. So if you're interested in cost savings, this might be a cool article. I'm going to read through it, so I'll pause it here, and then we can talk about it. Okay, so I just read through how we reduce Lambda function cost by thousands of dollars. It's a very interesting article by Mohammed here, so let's go ahead and scroll down into it. So what it's showing in this diagram is that this is actually what a small piece, he says, a small piece of their serverless infrastructure looks like. You can see a whole bunch of things happening here, everything from Jenkins to there's a MongoDB there, S3 buckets, CloudWatch. I think I saw Docker in there. They're using Elk Stack. They've got Redis. They've got Chrome. Probably scraping the web. Yeah, so it's a lot of stuff. And they said they were serving 80 million plus Lambda invocations per day across multiple AWS regions. And the unpleasant surprise they got was a huge bill. So here is what their invocations were. You can see that's the 20 million line up there. Certain days they were hitting 20 million requests per day. So they said it was very easy and cheap to build a Lambda-based application, that we forgot to estimate and optimize Lambda costs earlier during the development phase. Then they got heavy workloads in production, and the cost became spending thousands of dollars per day. So we look here, you can see that there's $2,000 a day. They exceeded that a couple of times. The majority of the time, though, they were right around like $1,000 plus per day, down to $500 up to $2,000. So they were spending quite a bit. If it was $2,000 a day and they did that, 30 times, was that $60,000 in spend on serverless for this application, which I think is getting like maybe 1 billion requests per month. I may be wrong on the numbers there. I'm not really using a calculator, to be honest. And so, yeah, I mean, even if it was $1,000 a day, it's still $30,000 a month, roughly. And so how do they reduce it? So what they did was actually kind of interesting. So they tracked the duration and the memory that was being used. So they were looking at a couple of things: the number of executions, duration rounded to the nearest 100 millisecond, memory allocated, and data transfer out to the internet, interregion, and intra-region. So then they had this flow here, which is really nice. They're using AWS Lambda to ingest the logs, CloudWatch, and then they're streaming those logs to Kinesis. And then they're using multiple shards to then shoot those over to InfluxDB, and then they're visualizing that in Grafana. And then they have this cool Grafana here. Let me actually just scroll it in this way. So on this bottom left, you can see the memory usage. So you're seeing that they're not actually getting above 500 MB. And on the bottom right here, they are getting the build duration that's actually running. I think it's showing something kind of weird. This is a weird, this is like milliseconds that's going on. So yeah, I don't know how helpful that graph is, to be honest. But then they kind of have these things overlaid on top of each other as a way to just show how much memory is being used from all these different functions and API endpoints. And then down here, they're actually running CloudWatch Insights. And then this is another way of gathering the memory and the duration for all these different ones. You can see here they're running a CloudWatch Insights, excuse me, for timestamp, build duration, as duration, and then the max memory of /1024. And then they're grabbing timestamp by descending. They're limiting the results to 20, and then they're filtering the message. So that then gives them back this information here. So it says that they leverage these metrics to set Slack notifications when memory allocation was too low, which would be a risk of failure, or too high for a risk of overpaying. They said that memory allocation can make a big difference in your Lambda function cost. Too much allocated memory and you'll overpay. Too little and your function will be risk of failure. Therefore, you want to keep a healthy balance when it comes to memory allocation. Cool. So to gather more insights and uncover hidden cost, they had to identify the most expensive functions. That's where Lambda tags came in. So using these Lambda tags and metadata to break down the cost per stack, which you can see down here. So using these Lambda tags, they're actually able to identify, I want to say that these are each individual stack. So Fox API, Clean Fox, Product Mapper, and you can see that their Fox API was costing pretty heavily. It's like 2,000, above 1,000 at least for like 10 days out of the month. And then they said by reducing the invocation frequency, so they're controlling the concurrency with SQS, we reduced the cost of the app by 99%. And so this is kind of cool. So you can see this here. So I want to say that leading up to this point, they were actually, yeah, so you can see there the cost was 79 cents on that day. So after they made that change, before they were spending, $400, $600, $800, and then it dropped all the way down to 79 cents. And that's a pretty huge difference there. And they said that they were using control concurrency with SQS to achieve this, and that was helping them reduce the invocation frequency. So right there, that's a pretty big way to save some money there. Deeper level, they broke down the cost by function name using a function tag. So you can see here that the no tag functions costing quite a bit. Then they identified other ones like Fox API users, as well as the Fox, it looks like both of those say Fox API users, regardless. And then moving a bit further down, they reviewed the execution flow and applied some optimizations in our code. So this is something that I wanted to point out because they did some code optimizations to shorten the running time and resources needed. So you can see here memory and CPU was optimized, and then they were actually able to realize some decent savings here. So on this end, on this far side, this is after they did all the optimizations, and you can see now that they're saving a lot more than before. So after they did these optimizations, they took it all the way down from like 1,300 at its peak all the way down to around like 250. And kind of their comments here at the very end were, by continuously monitoring and increases in spend, we ended up building scalable, secure, and resilient Lambda-based solutions while maintaining maximum cost effectiveness. And we are now configuring Lambda runtime parameters appropriately at the sandbox stage, and we're evaluating alternative services like spot instances and batch jobs to run heavy, non-critical workloads, considering the hidden cost of serverless. So I think that's a really good point at the very end. The hidden cost of serverless. We've actually seen some clients, after seeing this Lambda bill be as high as it is when you're working with high traffic applications, they've actually started moving towards something like Fargate, and they'll use Fargate and potentially ECS or EKS to then run these containers, where we've seen the usage of EKS for fully managed container using Kubernetes, and it seems like it works okay. They're able to basically run these containers as if it was a Lambda function, but they have a bit more control of it, and they're actually, I think they just came out with Fargate spot instances, and so it can be a lot cheaper to run those workloads in that way. But I don't actually have the numbers to, back that up off the top of my head. All right, so we finished off this article. I'm still coughing and dying, but we're going to keep moving on. So let's close this out. So this article is by Francois, it looks like, or Francis. I'm not sure how to pronounce it, to be honest. Sorry about that. But what this is going to be about is a serverless, the ideal choice for startups. And this is a cloud forecast case study. Cool. So this seems like a short-ish article, so I might just scroll through it and we can check it out. So the $100 startup concept. So cloud forecast. In his book, Chris advises readers to get their product out fast while being cost effective to limit the damage if your idea fails. And so the $100 startup, I did actually read this book actually, and this book is purely about putting the idea out there and then allowing people to use it or not use it. We've actually opened something up at Serverless Guru. This is our website here. You can see here that we do like serverless consulting, training, and migrations. Some additional information there. But just recently we added this extra tab here called support. And so I'm actually kind of excited about this. I helped make this kind of little thing here. So basically what this is about is developing serverless applications can be tricky. As your use cases grow, the complexity of your applications grow, the need for support grows, and developers are left in the cold reworking problems for hours that we already knew the answer to. So this is something that's been born off the back of doing consulting for the past 2.5 years or 3 years around serverless, is that, you know, I could see something that pops up in the terminal when you're using the serverless framework, and for me, I've ran into that so many times that I can solve it in, you know, I know what it is in like a minute, right? Versus somebody else where you may not know that's just a raw limitation of the serverless framework or CloudFormation or some underlying system. And so you might be confused, and that could take what took me initially, that 5 hours or 6 hours of that day or something to figure out and go down all the rabbit holes. I might have already gone down that, so I already know it's there. And in the same fashion, you know, the people that are on my team, they have, you know, 3 years of serverless experience, 4 years of serverless experience, and so combine that together, you know, we all have like 20 years of experience total in serverless, which is kind of cool. And we're all come from different backgrounds to kind of mix this together. But I also do this value prop here, which is like takes 6 hours to resolve at a rate of $50 to $80 an hour for each one of those occurrences. So each one of those bugs that takes 6 hours to fix, which, you know, sometimes you have to create a whole workaround for stuff, so it actually can take that long. Your company is losing $300 to $480 on each occurrence. So in normal, you know, reality, when you're developing applications, you find gaps, you write code around the gaps, you run into bugs, you fix the bugs, and that's pretty much how you build applications. It's a lot of trial and error and a lot of pulling things from different places and trying to make it work in your context. So the other thing that I say here is that if a developer makes a wrong serverless choice, not knowing the full scope of limitations, you know, in some cases that could be 2 weeks of development that could be thrown away. Meaning a minimum of 4,000 to 6,000 your company is losing on a single developer. So if you have to throw away 2 weeks of work, and let's say you had a team of two, one person or 4 people, this number gets exponential. So if it was 4 people, it's 16,000. If it's 1 person, it's 4,000. On the upper end, if it's 4 people, it's $24,000 that your company is losing. All based on the idea that you're making this decision based on the knowledge that you have currently. And if you're just starting with serverless, you may not have this kind of insight into it. And so that's where this consulting and this type of like offering here, which we've created, which is like serverless support, is kind of interesting, because you can then, you know, rely on our team to say, hey, you know, should we be using Lambda, or should we be using Fargate, or should we be using an EC2 instance, right? Like where is that line? And then we need somebody to evaluate it, and that's where this value prop comes in for serverless support, is that you know, you can rely on our team to basically tell you if this decision is worth doing or not, based on your traffic usage and based on the context for your company, your operational overhead, and your ability to actually, you know, follow through with all these things, right? Because there's like a raw cost and there's a like downstream cost. So if you choose to do the maybe Lambda's upfront, it's the cheapest option to build out, but then maybe the cost is higher for a high traffic app. But, you know, if you go to the container route, then you have to worry about managing the containers, the operational overhead, unless you're using something like Fargate and maybe an EKS mix. But then to actually get up to speed and have all these patterns developed, that takes a lot of time as well. And so in that way, very easily just there, right? Like I personally have spent, you know, 200 plus hours building out Fargate and EKS patterns. I've spent thousands of hours doing serverless development on AWS, and I've done a lot of EC2 instance development and things like that as well. And so I can very easily see the, you know, where these lines are and what makes sense for the company, and so can the rest of my team, which is nice. And so, you know, how does this kind of work? You fill out the form, and then we'll get in touch. Here are some benefits in here, you know, exponential downstream savings. Obviously, if you can save, it's like kind of that one of those things where, like, if you can spend $500 but it saves you $20,000, that's a really big benefit. Not saying that that's what this costs, but get in touch with us. Tell us about your situation. Give us the context, and we'll work with you. A few options there for you to look at, all that stuff. So expert serverless support for your entire development team. Why did I go down this rabbit hole? You may ask, why am I plugging this serverless support thing? One, I built it today, and so I'm kind of stoked on that. The other thing is that this $100 startup talks about being cost effective to limit damage if your idea fails. So that was my idea that I wanted to actually see done. And so to build that page out and actually launch it in the forum, about an hour. And in that time, I was able to get the page up and have the REST API connected as well. And so that's kind of what prompted this, is that, this $100 startup thing, if nobody uses it, it's fine. If people use it, that's great, and we'll build upon it. But I didn't go out and build a whole platform around it yet. I just opened up the door to it. If there is people that are looking for this, I have an idea for how to build a solution for it. All right, so on that note, I think that I'm going to call it, because I clearly cannot make it through 30 seconds of communicating without coughing and dying. So I really doubt that I'm going to get through what looks like 50 more articles. So I'm going to stop it here, and we'll just call this, part one of, Jeremy Daly's Off by None, issue number 50. So hopefully this is helpful, talking through all these things and getting my perspective on it, based on just being a daily practitioner of serverless and a consultant. If this is helpful, then let me know in the comments, and I'll do more of it. So this is the part one of potentially multiple parts of this. Assumingly, as I get less sick, I'll be able to do this in a much more streamlined fashion. If this video is not edited perfectly, and then you hear me coughing at different points, I apologize. That is not my intention. The sickness has been something that I've been recovering from for a couple of days now. I felt like I want to do things, and so I was like, you know what, I've thought about doing this for a long time. It's a big challenge, and I'm still going to do it, but I guess I'll have to wait a little bit until my voice is better. So anyways, thanks for watching, and I'll see you next time. Peace.